Learning something incredibly complex, maybe like neurosurgery, it can feel just overwhelming, right?
Oh, absolutely. It's a massive amount of information and skill to absorb.
Well, today we're diving into something that could really change the game. Using computer vision to analyze surgical videos. The idea is it could revolutionize how new neurosurgeons actually learn the ropes.
Yeah, make it much more efficient, more insightful. We've been looking at some fascinating material on this.
So the focus is really on how analyzing these videos with AI, computer vision, could be the bedrock for a completely new kind of training curriculum.
Precisely. Our mission today is to pull out the key ways this technology can, genuinely transform surgical education for trainees.
Okay, let's start with anatomical structure identification. That sounds pretty foundational.
It really is.
Mhm.
Imagine a trainee watching a video of, say, a temporal lobe resection that's a specific brain surgery.
Okay.
And as the surgery unfolds, the computer vision system automatically highlights and labels critical structures, like there's the hippocampus, clearly pointed out in real time.
Wow, so it's like having an anatomy tutor built right into the video feed.
Exactly. It bridges the gap between textbook diagrams and real applied anatomy in the operating field. It could seriously speed up how quickly trainees grasp those crucial spatial relationships.
I can see that. It makes it dynamic, not static. So moving on from identifying what you're seeing,
Yeah.
what about the flow? Does it help with understanding surgical phases?
Yes, definitely. Phase recognition is another big one. The AI can basically segment the entire procedure into its distinct stages.
Like the beginning, middle, and end bits.
Sort of, but more specific.
Yeah.
Think the initial incision, the craniotomy that's opening the skull, then maybe exposing the tumor, the resection itself, and finally the closure.
Okay.
A training system could actually pause the video at these transition points. It could say, okay, we're moving from craniotomy to tumor exposure now. Here's what typically happens.
That gives structure to what can seem like, a really long and complicated process. It helps build that mental map.
Precisely. Understanding that sequence, that flow, is vital.
And what about the actual doing part? Instrument tracking, how does that fit in?
This is where it gets into refining technique. Computer vision can track the precise movements, the usage patterns of surgical instruments in the video.
So you can see how an expert uses like a microdissector.
Exactly. For a trainee, you could visualize the ideal path, the optimal way to hold and move that instrument, maybe overlaid on the video.
Right.
Then they can compare their own movements, perhaps in a simulation, against that expert benchmark. It offers a visual guide to proper technique.
It's like virtual coaching for your hands. And I guess if you're tracking all this detail, could it lead to skill assessment?
That's certainly a potential application, yeah. It's maybe a bit further out, but the capability is emerging.
How would that work?
Well, by analyzing metrics like, say, the smoothness of movement, economy of motion, how closely the trainee follows established safe techniques, the system could provide objective feedback.
Interesting.
Or even just flag moments of really exemplary technique in expert videos for trainees to focus on.
Okay, this all sounds incredibly useful for learning, but how does the computer actually do this? What's the tech underneath?
It's all driven by machine learning, specifically training models on huge amounts of surgical video data that's been carefully annotated.
Annotated meaning labeled.
Exactly. Humans have gone through and labeled structures, phases, instruments. Then models, often things like convolutional neural networks or CNNs, learn to recognize these patterns visually.
Okay.
For sequences, for understanding the flow over time, we often use recurrent neural networks, RNNs. And for really detailed image segmentation, like picking out anatomical features, architectures like UNet are very powerful.
So it learns from real surgeries.
Yes, the key is it's learning from actual examples performed by experienced surgeons.
So let's put it all together. What's the vision for a new curriculum built around this?
The vision is really an interactive learning platform. It's centered on these CV-enhanced videos. Trainees aren't just watching passively anymore.
Right, not just hitting play.
No. They're engaging with videos where anatomical labels pop up, phase indicators change, instrument paths are shown. They might even be able to query things in the video.
That sounds much more engaging.
It is. It fosters a much deeper and likely faster understanding of both the anatomy and the surgical technique compared to just, watching a standard recording.
So it transforms the video from a passive recording into an active learning tool.
That's the goal. A dynamic, information-rich experience tailored for learning complex procedures.
It really feels like a significant leap forward from traditional methods.
We think so. It provides insights that are hard to get otherwise.
This is fascinating stuff. It really makes you ponder, doesn't it? How could this kind of AI-driven learning fundamentally shift how quickly and effectively we train surgeons, maybe not just in neurosurgery, but across all specialties down the line?
That's the big question, isn't it? The potential seems enormous.